So hello everybody. Today we're gonna try to make a YouTube video. I recently obtained this beautiful Simpson 260. It's a Series 5. Um, it was a little bit wonky. I had to replace the front panel, the glass panel, and all the wiring inside of being rebuilt because they was crumbling. But aside from that, everything now is working, up and running. It's really right on the money. But this is actually not the reason of the video. This one is. It's a transistor beta tester. It's a Model 650. And I never found a video about it online. And so I thought it was a great opportunity actually to have it on YouTube. So now I'm gonna quickly show you what it is. So there we have it. So we have few knobs. There's a battery adjustment. There's a function for PNP. It's a switch between PNP and NPN. There's a bypass, so you can use your multimeter's functions with this one attached. We have a beta switch. You have multiple voices here. So this one is the beta scales. That's to 50, 50, and 10, and the ICO, which is the ICBO, or the collector's beta leakage. We have the 0, obviously for calibration, and the battery calibrations. So, obviously, we have also a socket. This one is for placing transistor straight into it. And otherwise we have like 3 holes, 3 banana plug sockets, for collector, base, and emitter. And is basically the same over here. So now we're gonna try to assemble it, and I will show you how it works. We enlarge a little bit. So we need to remove the leads, place them aside. There we have it. And basically behind the front panel you have 4 banana jacks that you need to insert over here. You need to overlap the front panel to the instrument, and you need to flip it and lock it in the back like this. You need to switch the main knob to 50 microamps, and we need to place the cable. I need to pull it out a little bit. Sorry guys. Need to extend it a little bit. There we have it. Now it's gonna be good to go. And we need to place the jack to 50 microamps too. So now we are up and running. So now we can start and make some measurements. I have with me some transistor. It's FUOC75. It's a common transistor used in fast phase and other pedals, and in radius between the 60s and 63. I will place it in the sockets over here, and now we can start turning the function knob to PNP, which is a PNP transistor. We need to adjust the battery. There we have it. So the battery adjustment needs to set exactly in the middle, and you need to take the 50 scale and place it to 25. So now everything is set. Obviously this knob should be in battery mode, so you can actually do this. Now we can zero this out, we place it to 0, and now we need to wait a second that the germanium transistor will actually stabilize in temperature, because those kind of transistors are temperature related. We can wait a few seconds, and I'm gonna speed this up. So now we are ready, I think, to zero this out. Yeah, there we have it. I think now it's good. And now we're ready to flip the switch to ICO. ICO, which means ICBO. We flip, and we can write down, I think it's like 0.35. Yeah, more or less it's like, no, it's 0.3 actually. It's 0.3 microamps. No, sorry, it's 0.3 times 10 microamps, so it's 3 microamps. And then we're ready to flip the switch to 250, to the 250 scale, and it should be 105, 106, probably 107, close to that. Let's see if I'm trying to see if it's in the middle. I think it's 107, 108. Like, you can't wait too much time actually, because it's always going up, because the temperature, like the current now is warming up the inside of the transistors, and it will never settle. It will keep rising up. So it's not written in the manual, but I think after 10-15 seconds it's good to go. And I think after 10-15 seconds it was like 107 maybe. And now we can bring this back to ICO, and we can see in fact that the leakage has risen up because of the temperature rising, and we can maybe say it's 107. And now we have ICO and beta. So now everything is set. We don't need to do anything else. We can flip back this switch to off, and it's a good recommendation to place every time this knob to battery mode, so every time you start from there. So now I'm gonna take this apart, and I'm gonna show you some quick math, and then we're gonna see the inside and the inside modification that I actually performed on this potentiometer. So now we have the ICO or ICBO, and we have the beta. And if we want to know the full leakage current of the transistor, or the ICEO, which is the collector emitter leakage, we need to perform this formula, which is ICBO times the beta of the transistor, which is for us 3 microamps times 107, and it's 321. This one is the total. There we have it. Is the total leakage of the transistor. So this one is close to 110, 107, and this one is like 321. And now we have all the data that we need actually to match some other transistor. So now we will continue, and we're gonna give it a look inside of the beta tester. So now that we have seen how it works, we can see how it is inside. And I don't remember actually if I said it in the intro, but to find all the documentation, all the manuals and the operating stuff, you can Google for simpson260.com. I will include the link actually in the description, and it's a useful resource. There's basically everything about Simpson over there, and it's such a cool website. It's old school vibes for sure. It's like an early 2000 website, but you find everything there. Now, after removing the 4 screws, you just gently give it a pop. You lift this up, and now we can see inside. So we have we have the battery potentiometer. We have obviously 2 D cells battery. This one is the switch of the bypass switch. We have 2 rotors, one over here, one over here. We have the push-pull potentiometer that basically when you pull for checking power transistor or for checking really high leakage transistor, this one adds 910K if I'm correct. But the main modification that I've done is, since usually this kind of transistor was operated with this kind of battery 9063, and it was designed to operate again with lower voltages because of the manufacturers of this kind of battery, because under load it was less performant than our battery nowadays. Basically what I had to do is I had to modify the way you was setting the center of the battery. This 47 ohms resistor was in parallel with this 100 ohms potentiometer, and I had to take it out because I wasn't able to center the needle. Like, our battery, like nowadays batteries, are way more powerful than back then, and so it was always overloaded. And so I took away the 47 ohms from the parallel configuration, and I thought at first I thought 100 ohms was sufficient, but no. So I ended up adding this 47 ohm resistor to the potentiometers in series. So now it's 47 ohm plus the 100 ohms range to calibrate the instrument. And the other modification that I went through, it was, since those batteries are a little bit more thick, they wasn't fitting so well inside here, and if I was using his fork, his original fork, I was squeezing them too much, and what was happening is the aluminum over here of the housing was squeezing to the battery and basically was piercing through the plastic, shorting out everything, because this one is positive outside and negative only on the bottom. So everything was shorting out, and I just realized, like, after the first try. So I replaced the fork with a rubber band. It's a sturdy one, and I placed, for safety, some paper, some thick paper. This one is transformer paper, for example. This is really thick. It's difficult actually to pierce through it. Yep, and that's it. Obviously also the cable was crumbling, so I placed some, I just desoldered that, and I basically covered it with thermal tubing, and now it looks like almost original. Obviously it's not, but at least I kept the original banana jack, which I actually love it. So I was like, yeah, I don't want to replace it. Everything else is in spec, like all the 1% resistor are in spec. The instrument is just outstanding in my opinion, considering that it was made in 1968. So, speaking of conclusion, I mean, it's not obviously the good to go instrument. Maybe if you want to buy something new, I just found it for cheap, really cheap. It was like more or less like $50 for everything, for the instrument, the tester, the multimeters, and for the adapter. For me, it was really, really, really a good deal, and I thought it was a cool idea actually to restore it. And I actually like vintage equipment, so for me it was like a double win. But obviously, it's not precise as a digital one, a new one. I'm not talking about like the digital crap that you can find for super cheap. Those stuff usually are not accurate because it doesn't take into account the high leakage that usually germanium transistors have. So nope. If I mean this one is 1,000% more reliable than those kind of crap. But if you want to talk about, for example, like for like about peak electronic stuff, yeah, they are way more reliable. Like, but it's a cool concept. Again, I love vintage instruments and vintage equipment, and so for me it was like more or less like a restoration project. And actually this worked pretty well. I wasn't expecting at all that was this precise, like it's dead on. Like I had already the value for those transistors because I already measured it with digital stuff, and this is just right on the money. It's just after so many years it's still there. And of course you cannot measure newer stuff. It's like for silicon, for example, you need to there's some way to calculate the beta. You need to multiply the results for 1.16 if I'm correct, but you need to check into the manual. But still, you have a fixed amount of beta that you can actually measure correctly and with precision. So for me, it's yes, it's good for matching. It's good as I don't know how to say. It's good as a vintage equipment that you maybe can show or you can keep or you can collect. But obviously, if you want to rely on one thing, for me, it's better. Obviously, if you invest in something else. Obviously, this one comes with. This one came with a multimeters aside, and it's really useful because like you can use this one to check for capacitors, you can check for potentiometer, you can check a lot of stuff, and it's 100% functional and is right on the money. It's for me it's a double win. And but obviously if someone asked me like, yeah, I find it for $30, $50, and you have already a Simpson 260, like I'm dead on. Like, go for it. Like, it's fun, and I love it. I can't say anything else. Like, it's really good, a really good instrument. So for now, thank you for watching it, and I hope you like it, and I hope everyone will find useful this this video about this beautiful beta tester, and have a great day.